initial state is complete, you can use, it's actually written as CWA, you see it in some other places too, closed world assumption. Which basically means everything else other than these are false. Okay? Then I can apply these actions. So for example, if I apply pickup A to this state, I can generate a new state directly. I don't need a child generator function. I can just basically look at what are the things that pickup A is saying, pickup X is saying. So for example, for pickup A to be doable, it better be the case that A is on table and hand should be empty. A is on table, hand is empty. So I can do it. Then how do I construct the next state? In the next state, I know what will definitely be changing. The things that will be changing are given by the definition of pickup X. In the nuke state, X will be held, table, and it won't be on table, and hand would not be empty, and X won't be clear. So what I do in computing the next state is I write those things in the red, and write other variables. Every other variable that is not mentioned here, I just copy it over from the previous state. Algebra over the states. So this basically makes sense because the actions are changing only a few variables. In this case, the number of state variables is small. But in any rich world, there could be like 10,000 variables. Each action has local effects. It changes a couple of variables. So this kind of a representation of the action can be a lot more compact than the atomic representation of an action. In the case of atomic representation, all actions will have the same size. It will be number of states by number of states matrix. Do you see what I'm saying? If I do this, now I can get the next state, and similarly I apply the other action, I get other state, and so on. I now can do A star search on this, basically. Right? So I have a way of starting from the state, I can generate new states, and I know when to stop. I stop whenever my current state winds up having the goal variables to be exactly in the form I wanted. Do you see what I'm saying? So you can actually look at this and as a little exercise, do the version which we talked about, which is had you picked up A, stacked A on top of B, at that point you will get a state which should have not clear B and hand empty. And so you say the goal is done. Okay? This idea is called progression. You're basically going in the forward direction. I'm going to take a few more minutes, maybe 5 minutes maximum, to just complete the regression part. And then we will be done with this, and then we can talk about something else next time. So the regression part, since I mentioned this earlier, you can start in the other direction. You can start from the goal state. Remember, the goal state is not clear B and hand empty. It's not a real state. Right? Because any full state where clear B is false and hand empty is true is actually consistent with the goal state. Right? It's a partial goal state. Just like just pass the exam, and the shirt you're wearing on that day can be many, many different shirts. The pants you're wearing that day can be many, many different lengths. The length of your hair can be many, many different values. All I care about is that you pass the exam. Right? So it is actually surprising that I should be able to do backward search from this. In the normal A star search on a complete graph, you can always go either backward or the forward. In the case of child generator function, you can't go backward. Because the child generator function and goal test are, the goal test is, if the goal test is a piece of code, you don't know how to go backward. Here, instead of goal test being an opaque code, it's just telling me the goal will have these following variables having these values. Okay? So then I will start putting actions in the backward direction. Mind bending. What does applying an action in the backward direction mean? And by the way, the word for it is, since I call the other one progression, this one is regression. It's a different regression from the linear regression and stochastic regression in learning. It's the same word for a completely different meaning. Okay? Here you are basically regressing. Actually, the word regression here is close to what happens in programming language. If you are trying to check the correctness of the program, you'll take the program as a whole, you'll see what are the conditions it should satisfy, and then you regress those conditions through your program and say that the input satisfies them. That's how you prove correctness of programs. Okay? So that's, and it turns out a plan, a sequence of actions is a small program. It's actually a line program. Okay? So what I'm going to do here, I'm basically going to show that I can apply put down A in the backward direction here. And if I'm applying it in the backward direction, what it means is this has to be the very last action before this state. If this is the very last action before this state, then whatever this guy has not given has to be true before. Right? So put down A will give me hand empty. So I don't need hand empty here. But I still need not clear B, because not clear B was not given by put down A. If you're the last guy, right, then what must have been true before you such that the goal will be true after you? Right? And then of course, since you're the last guy, all your preconditions should be true before you. Otherwise you couldn't even have done it. So for put down A, what are the preconditions? Holding A. Write that. You see what I'm saying? Then there's only one other question. For example, can I do as the last action stack A, B as the last action? Can I do as the last action stack A, B? If you are the last guy and you did stack A, B, I'm sorry, stack A, B is actually fine. No, let me just see. What I do, stack A, B is fine. No, stack A, B is fine actually. That's what I did here. So stack A, B will work. Let's get something that, what I was looking for is pick up A. Let's do that. Let's just do pick up A. Can I do pick up A from here? And then 1 second. No, so the point I'm trying to make, actually, I'm blacking out right now, but the point I'm trying to make is, if you are the last guy, whatever you give, nobody else has to do. But if you killed one of the goals as the last thing you did, then nobody will bring those goals back. Do you understand what I'm saying? Right? If you are the very last guy, and so for example you had anything which gives clear B as an effect, cannot be the last action. Because if it is the last action, clear B will be true after that action. So you can't regress the state over it. So the one thing that's happening in the progression, you have to check the preconditions before applying the action. In the regression, we didn't say anything about that. It turns out there are preconditions there too. It is, you can only do the action if it doesn't kill any of the goals. And in which case, every goal it gives doesn't have to be given before it anymore. Anything it hasn't yet given has to be given before it. And all its preconditions have to be given before it. Okay? That is basically what is written there. And none of this, one of the interesting questions is, I can actually in the regression, I can do an action which doesn't have any useful effect, and that's still fine. That is, basically the last action that you do is sing a song. let's say. That doesn't change any of these variables. That's okay. Not being useful is a secondary thing. Not hurting the goal state is the primary thing. It's like physician's thing. Physician first don't cause any harm to the patient and then try to see if you can save the patient. So in the case of regression, you should make sure that the action has no effects that are inconsistent with what is in the goal state. If so, then you can do that action as the last one, and then any of the goals that it's giving, you no longer have to make it true before, everything else you have to make it true before, and then you add the precondition on the action. This is called regression. I'll stop here, think about it a little more, we'll talk a little more next class.
Go to